the concept of derivatives is central in calculus 1. Of differentiation. Is central in calculus 1. In any calculus 1, okay. I'm going to use a particular question to introduce the concept of differentiation, the derivatives, the same thing. Differentiation is the procedure of taking derivatives. Okay. We'll use a particular question to motivate the concept. So get your handout number 4. Okay, handout number 4. We're going to use part 1 to motivate the concept. I copied the question to the PowerPoint already. We'll go over the questions one by one. Okay. Again, the question on the screen is designed to motivate the concept of the derivatives, the definition of the derivatives. Okay. We'll go over the questions one by one. I think most of you guys have done some physics. Okay. Essentially, if you do not know the term displacement, you just imagine displacement is the distance. Okay. And here you have a distance function, a displacement function. Okay. You imagine the distance or the displacement is in meters, and there's a time t. You imagine the distance or the displacement is changing in terms of time t. The time now is in seconds. Again, t, the variable t is for time. Okay, and the value of the function is the distance. To understand the meaning of the function, we try to answer the first two questions. Okay. Now look at question 1. In question 1, we are trying to get the distance traveled by the object after 1 second. Again, if you did not know the term displacement, you just imagine the displacement is the distance. Okay. We'll answer the questions one by one. Now for question 1. For question 1, we are trying to get the distance traveled after 1 second. This formula shows you how the object travels, how the distance changes. Okay. Now for instance, after 1 second, you replace t value with 1, and then you have the distance traveled. Now to answer question 1, all we need is to evaluate the function at t value of 1. Okay, we compute t f of 1. So the value of the function is a simple question. Okay, a simple function. I'm trying to use a function like that to motivate the concept. Okay, to answer question 1, you just evaluate the function at 1. You compute 1 squared, right? So the answer is 1. If you want the unit, it means meters. It means you imagine there's a object. The distance changes according to time t. Okay, after 1 second, the object travels 1 meters. If you want the unit, it's in meters. Okay. Now let's work on question 2. In question 2, we are looking for the displacement or the distance traveled by the object after 2 seconds. In this case, the t value is 2. We are looking for the distance. So all we need is to plug the t value of 2 the t-value of 2 into the function. So we have f of 2, right? F of 2 is computed using 2 squared. Now 2 squared is equal to 4. Again, the unit is in meters. Simple enough, right? Okay, now look at question 3. 3 is simple too. Now we are going to get the distance traveled over the time interval from 1 second to 2 seconds. So anybody want to tell me the answer? I just want to make sure you're following me. You have warmed up. Okay. After 1 second, the object travels 1 meters. After 2 seconds, the object travels 4 meters. Now I'm looking for the displacement or the distance traveled over the time interval from 1 second to 2 seconds. Anybody want to tell me the answer, please? Yeah, 3 seconds, right? We just compute the difference between two values. So the answer to question 3 is simple. If you want me to show you how this number is computed, the number is computed by subtracting the two numbers you found in question 1 and question 2. So for question 3, it's computed using the value of the function at 2, the distance traveled after 2 seconds, right? And then minus the distance traveled after 1 second. That's how you get the distance traveled over the time interval. So I believe it's 4 minus 1, is that right? So that's how we get 3. If you want the unit, it's in meters. Again, for the guests who joined the class late, a little late, it's okay. But get handout number 4, please. Get handout number 4 from the website. That's part 1 on handout 4. Okay. Now look at question 4. In question 4, we are trying to compute the average velocity. Very shortly, we are going to use the average velocity to motivate the main concept. Okay. Now we are working on question 4. In question 4, we are trying to get the average velocity over the time interval from 1 second to 2 seconds. Okay. If you did not do physics, if you do not know the term velocity, you just imagine velocity as the speed. Okay. So in question 4, essentially we are trying to compute the average speed. The average speed. The object travels not at a constant speed. Okay. The speed changes. You are going to see it shortly. But we are trying to compute the average velocity over the time interval from 1 second to 2 seconds. Okay. Using your common sense, I'm pretty sure at least you can remember that. There's a relation between 3 things. One thing is the distance. The other thing is the velocity, the speed. The other thing is the time. The third thing is the time. There's a relation between the 3 things, right? Now how can we compute the average velocity? So anybody want to tell me the answer to the average velocity? The time elapsed is 1 second. The time elapsed is 1 second, is that right? From 1 second to 2 seconds. And then the distance traveled is 3 meters. For the average velocity, we are looking for how many meters per second traveled over that time interval, right? So in question 4, yeah, 3 is right. So did you guys told me 3? In 1 second, the object travels 3 meters. So the time elapsed is 1 second, right? Distance traveled is 3. So the average velocity in question number 4, I'm going to use kind of standard notation. V bar. V bar is kind of the standard notation for the average velocity. Okay. If you want the formula, is the distance traveled over the time interval is f of 2, the distance traveled after 2 seconds. Okay. So do not lose track of the meaning of all the values of the functions. F of 2 is the distance traveled after 2 seconds. And f of 1 is the distance traveled after 1 second, right? So that is on the numerator you have the distance traveled from 1 second to 2 seconds. Okay. And then the time elapsed is 1 second, of course. Okay, use 2 minus 1 to denote the time elapsed. Okay. So the answer to this one is of course 3 over 1. 3 over 1 is 1. Sorry, 3 over 1 is 3, of course, right? Now I just want to make sure you're following me. Okay. Anybody want to tell me the unit for question number 4? If I'm looking for the unit, the number I got is 3, and the 3 has a meaning. It's supposed to be average velocity. Anybody want to tell me the unit for question number 4? Yeah, meters per second. It's good. It's meters per second, right? We're talking about velocity. Velocity is kind of the speed. It's the rate of change of the distance. It's meters per second. Yeah, that's right. Okay, so we're done question number 4. This one, all the questions are designed to help you understand the meaning of the displacement function and average velocity and so on. Okay, now we're done question number 4. Okay, for all the questions 5, 6, 7, I want you to see something, to observe the change of the time interval. You see in question number 4, the length of the time interval, the time elapsed is 1 second. Okay, and in question number 5, so do you see the time interval is getting shorter and shorter? From 1 second to 1.1 second, the time elapsed is 0.1 second. 0.1 seconds, right? And for question number 6, the time elapsed is 0.01 seconds. So basically, we are going to make the time interval get shorter and shorter, and then we observe how the average velocity changes. So that's the whole idea. But we are going to compute some numbers. Okay. Now let's work on question number 5, 6, 7 first. Okay. Now let's do question number 5 first. Okay. In question number 5, we are trying to compute the average velocity over the time interval from 1 second to 1.1 second. Okay. I will still use the standard notation for the average velocity in question number 5. The average velocity is computed using. Okay, so do not lose track of the meaning. Okay. How can we get the time elapsed? The time elapsed is. So what is the time elapsed for question number 5? Now look at question number 5. The time elapsed is 0.1 seconds, right? Now look at question number 5. From 1 second to 1.1 seconds, the time elapsed is 0.1 seconds, of course, right? 0.1 second. Okay, now let's figure out the numerator. We're trying to get the average velocity. The numerator is supposed to be the distance traveled over the time interval. The distance traveled over the time interval is the distance traveled. I'm going to use the function notation. Okay, the distance traveled after 1.1 seconds minus the distance traveled after 1 second. Again, on numerator you have the distance traveled over the time interval from 1 second to 1.1 seconds. On denominator you have the time elapsed. So the average velocity over the time interval is given by that. It's given by that formula. If we use the function notation. Actually, it's easy to compute the value. Okay, to compute the value, probably you want to try at least one number. Okay, you want to try to compute this value. I will give you the next thing. Okay, the denominator is again the time elapsed is 0.1 seconds. On the numerator, you have the distance traveled after 1.1 second. The distance traveled after any t seconds is equal to t squared. So the distance traveled after 1.1 seconds is computed using 1.1 squared, right? And then minus the distance traveled after 1 second is of course 1 squared. Okay. So please, anybody want to use our calculator to get me the answer to this value? I need your help, please. I'm looking for the answer to question number 5. Just use your calculator, push buttons. Yeah, 2.1 is most likely right. So thank you. It's 2.1. Okay, 2.1. So the unit is in meters per second. Okay. As long as you know what's going on with question number 5, I believe for 6 and 7 I can move over a little bit quicker. It's essentially we're making the time interval gets shorter and shorter. We're going to observe the change of the average velocity, and then using that we're going to motivate the concept of the derivatives. Okay. Okay, now let's do question number 6 in here. I believe I have enough space to put question number 6 in here. In question number 6, we're trying to get the average velocity of the object over the time interval from 1 second to 1.01 second. I want you to know the time interval is shorter than question number 5, right? So for question number 6, the average velocity is computed using on denominator you have the time elapsed, so it is 0.01. Now look at the question. For question number 6, from 1 second to 1.01 second, the time elapsed is 0.01 seconds, right? And on numerator, we want the distance traveled is the value of the function at 1.01, so do not lose track of the meaning. So this one is the distance traveled after 1.01 second. And the minus the value of the function at 1 is the distance traveled at after 1 second. Okay. Okay, now we plug the numbers in. We have 1.01 squared minus 1 squared. On denominator you have 0.01. I think I got this right. Okay, you could press the button, but I think we practiced the other one, so maybe you want to double check I have all these numbers right. I believe the next number you are going to get is 2.01 meters per second. Okay. I did the calculation before class actually. 2.01 meters per second. Six is simple. 7 should be simple too. Now let's move on to 7. Okay. For 7, you know what I'm going to write, but still I'm going to write the answer to 7 in some more details. Okay. Average velocity, time elapsed on denominator, and the distance traveled on the numerator. I hope I wrote enough zeros. 2 zeros, I think. So this time I think we can guess the value. Okay, or you just look at my calculation. Okay, the next value is 2.001. 2.001. meters per second. Okay. Now the interesting things are not the values we computed in question number 5, 2.1, in question number 6, 2.01, in question number 7, 2.001. Okay. Now listen to my question. Okay. Now listen to my question. The question will give you the next thing. Okay. Now listen to my question. Now look at question 4, 5, and 6, and 7. 4, 5, 6, and 7. Now listen to my question, okay? As the time interval gets shorter and shorter, can anybody try to describe the change of the average velocity? The average velocity gets closer and closer to what number? I want to repeat my question, okay? as the time interval gets shorter and shorter, the average velocity gets closer and closer to the number 2. 2 should be in meters per second. Now we are going to answer question number 8. Okay, it's kind of important question. All of you guys told me I'm going to repeat your answer. Okay, as the time interval gets shorter and shorter, the average velocity v bar gets closer and closer to the number of 2. 2 should be in 2 meters per second. I hope it makes sense. 2 is in 2 meters per second. Okay, now think about that. Okay, as the time interval gets shorter and shorter, eventually as the time interval gets very short, the average velocity gets closer and closer to 2 meters per second. Now think about the following. What is the meaning of 2 meters per second? Anybody want to describe 2 meters per second? I'm looking for a term. Using what term you can describe 2 meters per second? What is 2 meters per second? So basically, the average velocity over a very, very tiny time interval. So what's the meaning of that? I'm looking for a term, please. Yeah, probably you learned that term in high school, but I'm trying to. Anybody? Yeah, instantaneous velocity. Instantaneous velocity. That's the term I'm looking for. Okay, actually, it's in question number 8. Okay, thank you, Alia. Right? Okay, so that's instantaneous velocity. Okay. Now let's try to understand that. I think many of you guys, you are in grade 12. So many of you guys, at least in grade 12, I think you are learning driving or got your license already. Okay, when you drive your car, at any moment your speedometer has a reading, right? At any instance, your speedometer has a reading. So what's the meaning of that reading? Now let's say if you drive on highway 100 kilometers per hour, okay. If you drive in city, so not 70, you cannot drive at 70, 50 kilometers per hour, okay. That reading is the instantaneous velocity. It's the velocity at any moment, okay. It's actually the average velocity over a very, very tiny time interval. So that makes sense? Now I'm going to write the answer to 7 on this screen. 8, I mean. The answer to 8. Okay. Use the above value to identify the instantaneous velocity of the object after 1 second. Okay. You see the time interval always starts from 1 second to some other seconds as the time interval gets shorter and shorter. Okay. Very, very close to 1 second. Sorry, eventually the time interval is very short, but the starting point is 1 second. So that's what I meant. Okay. Now look at question number 8. Use the above to guess. Now we only identify or guess the instantaneous velocity. So very shortly we are going to officially compute, okay, the average velocity. Now the answer to question number 8. Okay. So the answer is just the number you told me earlier. So the answer to question number 8, the instantaneous velocity after 1 second is actually 2 meters per second. Okay. So this one is the instantaneous velocity. Remember the term, we call it instantaneous velocity. Okay. So do you see, essentially this 2 meters per second is observed by observing some kind of limits, right? To make my point clear, now we are going to move on to question number 9. Okay. So this time we are going to do something more general. I will tell you what we are going to do next. Okay. At this point, you imagine h is a very tiny number, Now, for instance, if h value is 2, you have question 4. If h value is 0.1, you have question 5. If h value is 0.01, you have question number 6, and so on. I think you got the idea, right? Now in question number 9, we are going to compute the average velocity over the time interval from 1 second to 1 plus h seconds. You just imagine h is a very, very tiny positive number. I don't know what I did, but I was trying to copy. I think it's still in my memory. Okay, now we are going to work on question number 8. I mean question number 9. Question number 9. Okay. Still, so do not lose track. For question number 9, we are going to compute the average velocity over the time interval from 1 second to 1 plus h seconds. Actually, it's possible for h to be a negative number. So, but to make it easier, we just imagine h is a positive tiny number. I want to repeat the following argument. You just imagine h is a tiny positive number when we do question number 9. Okay. Actually, it's possible to interpret h to be negative. Okay. Okay. To compute the average velocity, we need the quotient of two numbers, right? On denominator you have time elapsed. On the numerator you should have the distance traveled. Now let's figure out the denominator first. Anybody want to tell me the time elapsed from 1 second to 1 plus h seconds? H is a tiny positive number. I'm looking for the denominator for computing the average velocity. The denominator is supposed to be the time elapsed. The numerator is supposed to be distance traveled, right? So what is the time elapsed? Yeah, h is right. If h is hard for you to imagine, you just imagine h value is 0.1. So we go back to question 5. Okay, but after you know that, you replace the time elapsed with any number h. Again, h can be any number. Can be 0.1, can be 0.01, can be 1, okay, can be any number. Okay, now let's figure out the numerator. Okay, the numerator now this time is. Anybody want to try the numerator, please? I know it's a little hard to type, but tell me the numerator, please. So maybe in terms of the function notation. In terms of the function notation, please. F of whatever. The distance traveled after 1 plus h seconds is given by the value of the function at 1 plus h. So that makes sense. And then the distance traveled after 1 second is the same thing. It's the value of the function at 1. Okay. And then the distance traveled over the time interval is the difference between these two numbers. Again, so do not lose track of the meaning. Okay. The displacement function is t squared. It means what is the displacement or what is the distance after t seconds. Okay. And then on numerator we need the distance traveled over the time interval. The distance traveled after 1 plus h seconds is the value of the function at 1 plus h. The distance traveled after 1 second is the value of the function at 1. Right. Alright. And then the distance traveled over the time interval is the difference between these two function values. We leave the answer to question number 9 like that. But when we do question number 10, we'll actually compute the value. Okay, we will actually officially compute the instantaneous velocity. You're going to see you're going to see how. Okay, now look at question number 10. Again, it's possible to write the answer to 9 in some different form, but at this point I do not need that. I'm going to use part 1 to motivate the concept of the derivatives. Okay, now look at question number 10. Now concentrate, it's kind of interesting place. In question number 10, for question number 9, I still want to use v bar to denote the answer. V bar is kind of the notation for the average velocity. Now in question number 10, we are looking for the instantaneous velocity of the object after 1 second. Sorry, I was trying to use the 5 seconds, but now it doesn't matter. We just use 1 second. Now for question number 10, I'm going to use v to denote the instantaneous velocity. In question number 9, we had the average velocity. Again, try to understand the meanings of the two notations. This v is for instantaneous velocity. Instantaneous velocity. This v bar is for average velocity. Now I want you to be able to answer this question. If you get this question, you get the whole idea. I'm looking for a relation between v and v bar. How do you connect v and v bar? Again, you imagine h is a very tiny positive number. In question 9, we got the average velocity over a tiny time interval from 1 second to 1 plus h seconds. Now in question number 10, we are looking for the instantaneous velocity. Now I'm looking for the connection between v and v bar. If it's hard for you to write, you can speak up or you can tell me a term. I'm just looking for one term. I will give you some hint. So does it make sense? As the time interval gets shorter and shorter, the average velocity gets closer and closer to the instantaneous velocity. I want to repeat, as the time interval gets shorter and shorter, the average velocity gets closer and closer to instantaneous velocity. What's that supposed to mean? I'm just looking for one term. The instantaneous velocity can be computed by taking what of the average velocity. Please, you know that. Try something, please. Every year some people can tell me the right thing. Do you remember what I told you? So what concept is fundamental in calculus? Everything is defined in terms of that. Try something, please. Limit. Yeah, that's something I'm looking for. So does it make sense? The average velocity is the instantaneous velocity is the limit of the average velocity as the time interval gets shorter and shorter. As the time interval, how do you describe as time interval gets shorter and shorter? The limit is taken with respect to as h goes to what? So please, as h goes to what? What do we mean by time interval gets shorter and shorter? Please. As h approaches, how do you describe as the time interval gets shorter? Try again. As the approaches zero is right. So does it make sense? As the time interval gets shorter and shorter, it means, okay, you look at the decimal number, the decimal places after this point. It's from 0.1, 0.01, 0.001, right? So that's the values of age, right? As the time interval gets, as age approaches 0. I know how you think of 1. If you think 1 as the right endpoint gets closer and closer to 1, but we're talking about there's an easier way to describe that in terms of age. So does that make sense? As the value of age gets tinier and tinier, approaching 0, the limit of the average velocity is actually the instantaneous velocity, right? Actually, very shortly you are going to see the definition of the derivative in the next thing. Okay, in the next thing is the limit as age approaches 0. I'm just copying the b bar, okay, from question 9. Okay, still it's a good idea to remember the meaning. On denominator, you kind of remember is the time elapsed, right? On the numerator, it's kind of the distance traveled. Okay. Okay, so that's it. That's kind of the answer to question number 10, but we haven't got the number yet. So very shortly, I'm going to tell you the number. But I can tell you right now, the formula in the box is denoted using. So can I write that in the box as well? It's denoted using this notation, f prime of 1. It's called the derivative of the function f at 1. The derivative of the function at 1. I'm going to write it down. It's called the derivative of the function at 1. I don't know where to write it. The derivative of the function f of x, f of t actually. So in this question we use t, right? At t value of 1. It's denoted using f of 1. The derivative is the central concept in calculus 1. So do you see it's kind of the instantaneous rate of change? Instantaneous rate of change. It means how fast the distance changes at the time after 1 second. I want to repeat, it's kind of useful later in the course. Okay, the derivative is given by that formula. It's defined in terms of the limit using that formula. I told you in calculus everything is defined in terms of limits, right? The derivative is the central concept in calculus 1 is defined in terms of limits. I also want you to see it's actually describing an instantaneous rate of change. Instantaneous rate of change. The velocity, it shows how fast the distance changes, right? It's a rate of change. It means how fast the distance changes. Okay. I know there could be too many things coming up all at once. So, but later on when we do questions, it's simple. So temporarily try to memorize the formula. Okay. Actually, there's a physical meaning of the derivative. The physical meaning is the instantaneous velocity. I'm going to show you the wording very shortly. But now we are going to compute the average velocity. Okay. Sorry, we are going to compute the instantaneous velocity using that formula. We're actually going to compute a number to get a number. Okay, I hope I have enough room in here. It doesn't matter. I will start a new slide just to make sure I have enough room. Now let's recall the setup. The function now is t squared. The displacement function is t squared in meters, right? And now the instantaneous velocity after 1 second. The instantaneous velocity after 1 second. Can I just use the derivative notation? The instantaneous velocity after 1 second is it's denoted using the derivative of the function at 1. So temporarily you just remember the notation. Okay. And the formula to compute the instantaneous velocity we just mentioned is taken when h goes to 0, right? So try to memorize the formula. It's not too hard to memorize. On denominator you have h, on numerator you have f of 1 plus h, right? And then f of 1, so we got this, right? Actually, it's not too hard to memorize. If you forgot, you just try to recover from the physical meaning. On denominator you have the time elapsed, on numerator you have the distance traveled, right? And then the whole quotient is the average velocity over the time interval from 1 second to 1 plus h seconds. And then you take the limits. You take the limit as the time interval gets shorter and shorter. You have the instantaneous velocity. Okay, so that's how you kind of memorize this. Okay, we're going to compute. We're going to compute this. The denominator is still h. Now the function f of t is t squared. So by that we mean at any t the distance traveled is computed using t squared. Okay. Now let's try to plug everything into the functions. F of t is t squared, and then how do you get the value of the function at 1 plus h? Wherever you see 1 plus h, you replace 1 plus h with the whole thing squared. I'm trying to say it's 1 plus h squared minus the value of the function at 1. The value of the function at 1, you know how to compute that. You replace t with 1, you have 1 squared. I made a mistake on purpose. So anybody want to tell me very briefly what mistake I made on purpose? I made a mistake on purpose. So just tell me a reason how I made a mistake. I did that because I have seen some people also did something wrong on the assignment. I marked your assignment 1, by the way. In this case, the brackets are essential. Without brackets, it means completely different things. Okay. Do not forget brackets. To get the value of the function at 1 plus h, we need 1 plus h, the whole thing squared, right? So because we want to replace t with t squared, in this particular case, t is 1 plus h, right? So do not forget brackets. It's super essential. Okay. Actually, so don't worry. I'm kind of happy with your assignment. I think most of you guys should be okay. And by the way, so this is the course I need to use everything you learned in past many years, not only pre-calculus 12. I say that so because I want you to recall one of the formulas. I need to multiply out 1 plus h, the whole thing squared. I want you to recall formula a plus b, the whole thing squared. If you want to multiply them out, you'll have a squared and then plus 2ab, right? And then plus b squared. That's a formula I need to use in this particular case. Okay. Now we are going to compute the limit. So this term expanded to your a value is 1, your b value is h. Okay, so you have a squared, so it is 1, and then plus 2ab, 2h, right? And then plus b squared, h squared. Again, I was using the notations in that formula. A value is 1, b value is h. Okay, and then minus 1. Of course, 1 squared is 1 in here. Okay, and then on denominator you have h. So do not lose track. We are trying to evaluate the limit. The answer to the limit is going to be the instantaneous velocity, right? Okay, now you see the numerator 1 and a negative 1 is cancelled. Okay, and then so do you see the function of h now is undefined at 0? 0 will make the denominator 0. Okay, so we have to do something to get rid of h. I think last time I called h the bad egg. We want to do something to get rid of the bad egg. Okay, so basically we want to do something to cancel out h, right? So do not forget to copy down the limit notation. You need to write down the limit notation all the way down until kind of the last step. Okay. On denominator you still have h. On numerator you'd better so not to cancel right now. Okay. Try to remember another slogan, a common mistake actually. Factor before canceling. Now remember factor before canceling. I'm trying to say factor the numerator first before you cancel out h. I'm trying to say in these two terms you have a common factor of h. You take out h and then you have 2 plus h, right? You really should know how to factor this. At this point you can cancel out h. I will give you one more step. Or anybody want to tell me the final answer? After canceling out h, this function now is elementary. Function can be written using one formula. Function is defined at 0. So we can plug h value of 0 in to get the answer of limit. Okay. The answer to a limit is a number, right? The final answer. Anybody want to tell me the final answer? Please. Plug h value of 0 in. You can see the final answer. I think the final answer is 2. Yeah, the final answer is 2. So do not lose track of the meaning. Now we are trying to compute the instantaneous velocity. Instantaneous velocity. Now I'm looking for the unit actually. It should be in meters per second. Okay. That's how we officially compute the limit. In the future, if I want you to evaluate the limit, you have to use properties of limits, something like this, to compute the limit. So that makes sense? I'm trying to say, now look at question number 3, 4, 5, 6, up to 7. From question 3 to 7, using these numbers, it's possible to guess the limits. You guess the limit of 2, right? As the time interval gets shorter and shorter, these values are getting closer and closer to 2. So this is the way to guess the limit, to identify the limit. The wording I think I used is identify. Okay. But if I actually want you to evaluate the limit, to compute the limit, to calculate the limit, however you say it, I'm looking for a way like this. So this is, you see this is more general. H can be any number. So that makes sense? H can be any tiny number. In particular, in question number 9, H can be any tiny number. I hope you can see question number 9 covers question number 4, 5, 6, 7, and 8. When H value is 2, you have question number 4 When h value is 0.1, you have question number 5, and so on, right? And then that's the official way to evaluate the limits. Good, so good enough. Any questions? I told you the definition of a super duper important concept, the derivative. Okay, that's the central concept in calculus 1. Sorry, I'm looking for a file. I forgot. I think I accidentally closed. Now I'm going to show you the official statement of the physical meaning of the derivative. Okay, so first of all, the definitions here. Now you look at the definition. Okay, I used a particular question to motivate the definition. Actually, in the question, a value was 1. I believe you can imagine a value can be replaced with any number. Later on, we are going to practice a few questions, many questions actually, how to use this formula. Okay, but that's the definition of the derivative. We say the notation is f prime of a. So this number is denoted using the derivative of the function at a. The answer is a number. We did that, right? In the question, a value was 1, but we can replace 1 with any number. Essentially the same thing. Okay, actually, I'm blind. I was looking for this. In this remark, you have the physical meaning of the derivative we just mentioned. Okay, if the function is interpreted as the displacement function, or you imagine as the distance function of a moving object, then the derivative is the instantaneous velocity after a seconds. At this point, I hope it's not too hard to understand that. In the particular question, we did a value was 1, right? We were talking about the instantaneous velocity after 1 second. So basically, we are going to practice many questions, a few questions regarding how to evaluate the derivative of a function at a number. Okay, now you look at question 1. In question 1, the function is square root of t. The function g of t is square root of t. We are looking for. So do not forget how we say this number. This number is called the derivative of the function g at 9. Okay. The derivative of a function at a number is defined as the limit of a different quotient. We said it, the limit of a difference quotient. Now look at the definition. The definition is here. You can remember it's the limit of a difference quotient. On numerator you have a different. The whole thing you have a quotient, right? It's the limit of a difference quotient. Can I require you copy the formula so you have something to follow? Okay. I want you to copy the formula for the particular a value of 9. The general formula, you replace a value with 9, you have the formula. That's what I meant by copying the formula. I mean, the function notation is g. In this particular case, we do not use f. Okay, it's g of 9 plus h, a plus h, minus the value of the function at 9. On denominator, you have h. Compare that with the formula for the derivative. I was trying to say that formula. Okay, a value is 9 in that particular question. F function notation is g. Okay. Okay, the next step is kind of plug in. We plug, so by that we mean we replace, wherever you see t, you replace t with 9 plus h, you replace t with 9. So by that we mean, so can I just say that term is the value of the function of g at 9 plus h? The function is square root of t. You just replace t with 9 plus h. You have square root of 9 plus h, right? Square root of t is replaced with square root of 9 plus h. And then the value of the function 9, the value of the function 9 is square root of 9. You see it's square root of 9 is 3, right? You just replace the function with that. Simple. So let me know if you have any questions. In the next, again, the first thing I want you to do is to copy the formula, but replace a value with 9 in this particular case. Okay, and then you end up with this. Now the problem is how to compute the limit like this. You remember last time I told you a technique for evaluating a limit. Now we're practicing how to evaluate the limit. Now actually I'm trying to combine two new things into one thing: the definition of the derivative and how to evaluate the limits. Okay. In general, if you see a radical, in particular a square root in the limit, so what we do is to rationalize the numerator. I want to repeat, we rationalize the numerator. By that we mean the way to rationalize the numerator is we try to do something to get rid of the radical on numerator. I'm pretty sure you learned that in high school. Okay, we multiply the numerator and the denominator by the, now listen to my term, by the conjugate. I said the conjugate. I think J, sorry, that's spelling wrong. We multiply the numerator and the denominator by the conjugate of the numerator. That way we can get rid of the radical on the numerator. You do not have to care about the term, but we want to, you're going to see what's going on next. Okay, now we multiply the numerator and the denominator by the conjugate of the numerator, by the conjugate of that. The meaning is you just multiply, if you have square root of something minus a number, then you multiply by the square root of the same thing plus the number. You replace the sign in here. Okay, you multiply the numerator and the denominator by square root of 9 plus h plus 3. Again, the stuff in the second bracket is called the conjugate of the stuff in the first bracket. You just replace the sign. If you had a positive, you replace with negative. If you had negative, you replace the sign with the positive. Okay, that's the conjugate. Of course, you want the equation to be valid. You multiply the numerator by the conjugate of that. You have to multiply the denominator by the same thing, right? I'm trying to say you have to multiply the denominator by the conjugate of original numerator. Again, that's the second technique. I'm going to write it here. The first technique was to factor, right? The second technique, so today you are going to see something. We also need to factor. The second technique is to rationalize. In this case, we rationalize the numerator by multiplying the numerator and the denominator by the conjugate of the old numerator. You see the equation is valid. Okay. You're going to see what's going on next. So do you want to recall a formula I told you last time? So this time we use that formula the other way around. On the numerator, now you have the form of a minus b times a plus b. Anybody want to recall how to multiply out a minus b times a plus b? That's how this thing will work, how the rationalizing will work. In general, a minus b times a plus b, you have the form of a squared minus b squared if you multiply them out. So just remember that formula. You do not need to use something called multiply out or FOIL. You really do not. So you really do not need to FOIL. Okay. If you FOIL, you should have the same thing, but it's much easier if you just use that formula. You're going to see what's going on next. For denominator, you just keep that form. So just imagine. So just remember when evaluating a limit, we like the factored form better. The denominator is already in factored form, so you do not multiply them out. Okay. For the numerator, we want to use the formula I just mentioned to multiply them out. You have the form of a minus b times a plus b. Okay. Now you have a squared. In this particular case, a squared is square root of 9 plus h, the whole thing squared. So does it make sense? You have 9 plus h. It's something like square root the whole thing squared is equal to 2, right? But you do need to make sure 9 plus h is positive. But h is tiny when taking the limit. 9 plus h is positive. So does that make sense? And then minus, this part is a squared. So what's b squared? B squared is 9, right? I hope you can follow me. I did nothing but using that formula. You have, now look at the mouse cursor. On the numerator you have a minus b times a plus b. So using that formula, I have a squared minus b squared, right? At this point, the 9 is cancelled, right? 9 minus 9 is 0, right? After canceling out on 9, you can cancel out h from the numerator and the denominator. So do not forget the numerator is 1, it's not 0. After canceling out h, you still have 1 on the numerator, of course, right? Okay. Now the final answer. Now we're ready to have the final answer. So anybody want to tell me the final answer, please? Again, so do not forget to copy the limit notation all the way down until here. But after plugging h value of 0 into the function, we can get the answer. Anybody want to tell me the answer, please? I think I did something wrong here, so sorry about that. I did something wrong here. So here should be plus. We multiply the numerator and the denominator by the same thing. Here should be plus. So I'm sorry about that. Okay. Now the final answer, please. Yeah, 1/6 is the final answer. A little bit more comment. Some people just say you treat this part as 1, right? So this fraction times 1 is the same thing as that quotient. Okay, we did question 1. Actually, we did question 1a. So question 1b is simple actually. If the function g of t is interpreted as the displacement function of a moving object, now I want you to interpret the meaning of this answer. Now how do you answer question b? How do you answer question b, please? Actually, to practice the question of evaluating the derivative, I'm just using some assignment questions. So not the same ones, but very similar ones. So what's the meaning of this? What is the meaning of this number, 1/6? Instantaneous velocity, right? Okay, so the answer to question number B is you'll write something like this. So maybe the instantaneous velocity, right? Yeah, the instantaneous velocity of the object after how many seconds? 9 seconds, right? So 9 is here. 9 is t value in here. After 9 seconds, the instantaneous velocity equals 1/6. If you want the unit, you can say meters per second. Okay. The wording could be a little bit clumsy. I think I like 1/6 meters per second is the instantaneous velocity after 9 seconds, right? However you say it, as long as the meaning is clear, it's fine. Okay. Now remember the second technique I just told you, rationalizing. Okay. Now for question 2, I'm going to do this question, but I will modify this question for you guys to do a similar question for the assignment. So how about it? I will replace this 4 with some other number. Okay. For the same function, I'm going to replace this 4 with what number you want. So maybe 3. Okay. I'm going to replace this number with 3. So we're trying to compute the derivative of the function h at 3. So use proper function notations. Okay. Actually, we do not always use f to denote functions. Commonly used notations are f, g, h, and so on. Okay. Essentially the same thing. We are going to use the same formula for a different function to evaluate the derivative of the function at a number. Okay. So copy the formula first. As h goes to 0, right? Denominator is always h. The numerator is the value of the function at 3 plus h, right? 3 plus h minus the value of the function at 3. H. We are so used to use the notation of f, right? Now I want to use h. So good enough. Okay, now we are going to plug the numbers into the functions. The value of the function at 3 plus h. So this one is simple, right? Wherever you see t in the function, you replace t with 3 plus h. So that can I just call it the value of the function h at 3 plus h? It's 1 over 3 plus h. Again, so this is the value of the function at 3 plus h. Minus the value of the function at 3, I think it's 1/3, is that right? This one is kind of, and yeah, now you need to recall how to subtract two fractions. How to subtract two quotients is the same thing as subtracting two fractions. Okay, I'm pretty sure you know this, but so just in case some of you guys has been out of school for a longer time, you need to recall this. How do you subtract 1/3 from 1/2? You convert two fractions to two fractions with a common denominator. In this case, the common denominator is 6, right? You want to write two fractions to two new fractions with a common denominator. 1/2 is the same thing. 1 out of 2 is the same thing as 3 over 6. 1/3 is the same thing as 2 over 6, right? After converting two fractions to two new fractions with a common denominator, and then to subtract two fractions, you keep the common denominator. You subtract two numerators, right? You can do that on calculator, but you cannot do this on calculator. Actually, the same thing, right? H, the denominator, so there's nothing you can do about that. You just copy this. And then for the numerator, we are looking for a common denominator. I think you know the common denominator is 3 times 3 plus h. And by the way, the multiple of two denominators is always a common denominator. It may or may not be the least common denominator. I mean, it may not or may not be the best one, but it's always a common denominator. Okay. For the if you want to write the first quotient as a new quotient without denominator, so the top has to be 3, right? And then 3 times 3 plus h. I think all of you guys know that. If you do not know that, then you could be in trouble in this course. Okay, now we have converted two quotients to two new quotients on the numerator with two common denominators. If it's a real face-to-face class, I would ask you to practice some questions. I could check your work, but I cannot do that when teaching on Teams. You keep the common denominator, okay? You keep the common denominator. Anybody want to tell me the numerator? So just tell me a numerator. So please, so just tell me the numerator. Negative h is right. Negative h is right. So negative h is right. So don't be confused, okay? That's actually a common mistake. So do not write h in here. Do not write h in here. I'm going to write a long way and then I'm going to remove that soon. Okay, but you're trying to do what you're trying to do is 3 minus the whole of, I said the whole of 3 plus h. Later on, h is going to be negative, so do not forget the numerator is negative h. It's kind of the brackets thing, right? The brackets is essential in this case. So in here you have negative h. Does that make sense? That's why I said many of you guys are good. That's actually a common mistake. I have seen people using h in here all the time, every year. So just be careful, okay? For some reason, for whatever reason, so later on, if you want, I can tell you the reason. But at this point, it's permissible to cancel out h from here and here. I will give you the next step. After canceling out h at these two locations, the limit now becomes the limit as h approaches 0. On the numerator you have -1, right? On the denominator you have 3 times 3 plus h. Okay. Again, it's permissible to cancel out h this way. If you want, I can tell you a little bit long story. I'm going to remove that later. Okay. Negative h in here. It's not part of the solution. I'm trying to tell you why we can cancel out h that way. Okay. Now the numerator is negative h over 3 times 3 plus h. Okay. And then divided by h. To divide, now you need to recall fraction division. Dividing something is multiplying the reciprocal, right? So by that we mean dividing h is the same thing as multiplied by 1 over h. So do you see that's how we can cancel out the h to get this? I hope you guys are okay with that. At this point, we can. What the answer to the limit? I think we're ready to get the limit. So the answer to the limit is negative 1 over 9. Is that right? You plug h value of 0 into the function. You have the final answer. And by the way, in the final answer, you do not include the limit notation. It's kind of the limit of a function is a number. I told you that before, right? The limit of a function is a number. It means negative 1 over 9 is the limit of the function as h approaches 0. The limit of a function is a number. I forgot this 0, so do not forget that. Okay, so that's the complete solution to a. So that's how we got the derivative of the function. Okay. After getting this, you know how to answer question B. Okay. To answer question B, I will try to answer the question B in slightly different way. So negative 1 over 9 meters per second is the instantaneous velocity of the object after how many seconds? After 3 seconds, right? That's the interpretation. If the function is interpreted as the displacement function. Okay. That's the third technique. The third one is I don't know how to describe that, but I always call the third technique as manipulate. So by that we mean you change the function to some different forms so that you can get rid of the bad egg. In this case, you want to cancel out h so that you can get the value of the limit. Any questions? If you don't have any questions, I'm going to go over a question on the handout. So maybe handout number 4. I will see if there are interesting questions. And by the way, I have to modify assignment a little bit. We thought I could have time to cover tangent line thing, but I want to concentrate on the velocity stuff. It's okay. I'm going to make up a question actually. Okay. Probably using that. X squared minus 6x. So this time I'm going to use f. Okay. Can I still use t? Actually, I'm going to use f. I'm not going to talk about the physical meaning. I will use that function. X squared minus 6x. Can I make the function a little bit more complicated? And then plus 2. Okay. If the function is that, if I want you to get the derivative of the function at whatever number you want, so maybe 2. Okay. Now we are going to evaluate the derivative of the function at 2. In most cases, it's okay to say f prime of 2, but I still prefer to say the derivative of f at 2. We still have 30 minutes. Sorry, I'm going to change my mind. I will talk about one. It's okay. It's okay. So we'll just do this question, okay? Sorry, I was thinking about something different. The derivative of the function at 2, we copy the formula. I told you to copy the formula first, okay? The formula is the limit of a difference quotient. The limit of a difference quotient. Okay. This part is always the same. H goes to 0. We take the limit with respect to that. And then on the numerator you have the value of the function at 2 plus h minus the value of the function at 2. Okay. That is the basic formula, the formula for computing the derivative of a function at a number. For a question like that, you just need to be careful. Okay. Try not to make. I think you guys prefer to call it dumb mistakes. I make those mistakes too. The denominator, so there's nothing you can do about that. Now you watch the function. Okay, the function is x squared minus 6x and then plus 2. This thing is, now look at the mouse cursor. So this thing is the value of the function f at 2 plus h. wherever you see x, you replace x with 2 plus h. So you have x squared. Now try to use brackets, okay, to avoid some mistakes. X squared minus 6x. I said x, I wrote wherever I said x, I replace x with 2 plus h. X squared minus 6x and then plus 2, right? And then the next part is the value of the function at 2. The value of the function at 2, you just plug 2 into the function. Now let's do it separately here. The value of the function at 2 is equal to 2 squared minus 6 times 2, I think you have 12, and then plus 2. Anybody want to tell me this value? 4 minus 12 plus 2. Is that right? I think it's 14. So if you want, you can try it here on your own. We should have the same thing, and then we could compare the answers. Okay. On denominator, you have h. On numerator, you know which formula I'm trying to use. You have a formula a plus b, the whole thing squared. You have a squared. And then plus 2ab. Final answer. Sorry, it's not 14. I think it's not 14. Sorry about that. I think it's negative 6. Sure, thank you. It's minus negative 6, right? Okay, now we go back to this 4 plus 4h, and then plus h squared. Multiply out that term, I think you have negative 12, and then plus 6h minus 6h. And then plus 2 plus 6. I think most likely we got everything right. Most likely we got everything right. If you see all the numbers are cancelled, 2 plus 6 is 8, and then plus this 2 is 12, and then you have a negative 12 in here, right? After cancelling out the constants, you probably want to combine the terms. I think you have negative 2h. So watch me, please. I could make mistakes in here. 4h minus 6h. You have negative 2h, and then plus h squared. Okay. Now remember, I told you a factor before cancelling, right? Factor before cancelling, please. You take out h, negative 2 plus h, right? The numerator has a common factor of h. You take out the common factor of h. In the brackets, you have negative 2 plus h, right? Now you can cancel out h. Final answer, you should have negative 2. Okay. Any questions? Or anybody sees anything wrong?
I'm just wondering, how did you cancel out the constant numbers in the second to last step, like the 4 and the minus 12?
Yeah, I see. Uh, okay, you just look at all the constants. Uh, the positive numbers, you have 2 plus 4, which is 6. And then plus that 6, altogether you have 12. And then you have a negative 12 in here. So all the constants combine to 0.
Oh, okay,
So,
I see it now.
so that makes sense? Sure, thank you. Cool.
And then the 4h, shouldn't it be 2h because you would bring the 2 in and it would be a 4?
No, I think that's for each. So, are you talking about this term?
Yeah, because you just
Okay,
bring
okay.
the 2 in and then it would be
So
4 plus 2h.
okay. So listen to me. I'm trying to use this formula to expand. Okay. So the general formula is a plus b, the whole thing squared equals a squared plus 2ab, and then plus b squared. So a value is 2, b value is h. Okay. A squared is 2 squared, so which is 4, right? So what's 2ab? 2ab is 2 times 2, then times h. So you have 4h. And then plus b squared, your b is h squared. So that's how I got so these three terms. Okay. Any other questions? Okay, if you don't have any other questions, I don't have time to talk about why, but I'm going to tell you the geometric meaning of this number. We mentioned the physical meaning. Now I'm going to tell you the geometric meaning. I do not have time to tell you why, but I want you to remember the geometric meaning. Okay. Actually, if you look at the handout, my part 2 is designed to motivate the geometric meaning, but I do not have time to go over that. But I want you to remember the geometric meaning. I'm trying to say, remember this part. Okay, remember this part. The derivative of the function at a number a is the slope of the tangent line to the graph of the function at the point when x coordinate is a. I will copy this to the PowerPoint. I will show you the meaning. Okay. Maybe I'm going to use decimal to sketch the graph. I will show you the meaning. Okay. The function has the equation x squared minus 6x and then plus 2 x squared. I was trying to show the meaning, but I decided to do it later. But the function has the equation y equals x squared. Forgot the function already. Minus 6x and then plus 2 minus 6x and plus 2. So did I got the function right? Oh my gosh, so that's a parabola, but yeah, this parabola is kind of like that. Okay. You see the function, the value of the function at 2 is -6, as you told me earlier, right? Okay, now I'm going to try to sketch the line. Okay. So what's the slope again? So -2. So that's what I want. That's what I want. Okay, now I'm going to tell you the geometric meaning. Okay, when x value is 2 on the parabola on the graph, you have a point in here. You have a point in here. The point has x coordinate of 2 and y coordinate of -6. You have a point in here. So do you remember we found out the slope, the derivative of the function is -2? Now I'm going to talk about the geometric meaning of the derivative. At this point on the graph, on the parabola, at this point with x coordinate of 2 and y coordinate of -6, there's a tangent line to the parabola, to the graph. This tangent line has a slope. The slope of the tangent line is -2. -2 is the derivative. Okay, I'm going to write down the wording. Okay, in this for this particular question, I have to open a new slide. Geometrically, the slope, so just copy it down. Okay, the slope of the function. The function has the equation of, I forgot the equation already. X squared minus 6x and plus 2. X squared minus 6x and plus 2. Geometrically, the slope of can start over. Still copy this. The slope of the tangent line to the graph of, that's where I need that, to the graph of the function at the point where x value is 2 equals the derivative of the function at 2, which is, according to our calculation, which is -2. I told you the geometric meaning. Okay, the geometric meaning of the derivative of the function at 2 is the slope of a line, the slope of the tangent line. The tangent line is the tangent line passing through the point when x value is 2. So did you see it in here? The black line is the tangent line. The black line has a slope of 2. The slope and the curve, I'm trying to say the line with x coordinate of 2 and y coordinate of -6 is on the line, also it's on the problem. Okay. The point is the slope of the tangent line to the graph at this point is -2. That -2 is the derivative of the function at this number of 2. Okay. The derivative, to put it short, the derivative of the function at 2 is the slope of the tangent line. Alright. Probably the next question I'm going to make up one more question. Okay. To make up one more question using question number 4. Okay. In question number 4, if I want you to find the equation, actually when I drew the graph using decimals, I did that equation mentally. I'm going to show you how I got that equation. Okay. The next question is to find the equation of the tangent line. To the graph of the function. I think the function is still in the memory. I don't know what I'm doing. It's a little messy. If I want you to find the equation of the tangent line, so that's better. To the graph of that function at the point where x equals 2, how can we do it? I will show you how we do it. Okay. Now the solution to that. In any case, you have to get the slope first, right? According to question 3. According to question 3, okay. The derivative of the function at 2 is equal to -2. This gives the slope. You remember the geometric meaning? The slope of the tangent line. Anybody want to recall to get the equation of the tangent line? So what other thing do we need? Of course, you need the slope. You could get the intercept, but as long as you can get a point, then we can have the equation of the line. So that makes sense. In high school, you learned something called point-slope form. So by that we mean if you know a point on the line, if you know the slope of the line, then you can get the equation of the line. Okay. According to question 3, we know the slope already. Okay. Now we need a point. We need a point. How can we get the point? We know x coordinate of the point, right? In order to get the point, you also you also have to get the y-coordinate of the point. So by that we mean you have to evaluate the function at 2. Evaluate the function at 2, right? We are trying to get the point when x-coordinate is 2. You have to get the y-coordinate. Y-coordinate you can be computed by can be obtained by evaluating the function at 2. 2 squared minus 6 times 2, right? And then plus 2. I think you told me before this value is negative 6. So the point with x-coordinate of 2 and the y-coordinate of negative 6 is a point on the line, on the tangent line. So do you want to recall the point-slope form? Point-slope form is not part of the solution, but I'm going to recall the point-slope form. Okay. I do not have the space to write the full sentence. But in general, if you know a point on the line, the point is the point with the x-coordinate of A and the y-coordinate of B. And also if you know the slope of the line, how can we get the equation of the line? Point-slope form. Point-slope form of the line is y minus y-coordinate of the point equals the slope and then times x minus x-coordinate of the point. So this is the point-slope form, right? Remember that? Okay. After that, we can get the equation of the line. Again, the slope is negative 2. The point has x-coordinate of 2, y-coordinate of negative 6. Negative 2 is your value of m, right? 2 is a value. Negative 6 is b value. So the equation of the line. Equation of the tangent line. Okay, y minus y-coordinate of the point minus negative 6 is y plus 6 equals the slope negative 2, right? And then times x minus x-coordinate of the point. X-coordinate is 2. That's how I got the equation of the line. That's how I got the equation of the tangent line. You see the tangent line has that equation. I just did the whole thing mentally earlier to get the equation of the line. Again, the key point, the main thing is the slope of the tangent line to the graph of the function at this point is the derivative of the function at 2 in this particular case. Okay.